Hello YouTube family. So today we are going to do this 1895, that is largest matrix square. The problem statement is really simple. We are given a grid. It can be a rectangle, it can be a square. It's a grid that is being given, and we need to find the maximum square. That they have given some special condition for that. So the sum of the column and the row as well as the diagonal should be the same. So in this given example where 5131, this is the given grid, and we need to find what is the sum, what is the square that is possible where the sum of all the rows, sum of all the columns and the diagonal are same. So over here if we see 5131, what is the sum? That comes out to be 12. Then 5910, that comes out to be 15. Now if we go ahead and check this, I'll mark it with green. So this square that is present in the middle, 333, sum of the row is actually 6, sum of the column is actually 6, sum of the second column is also 6, second row is also 6, and diagonal is also 6. So if this is true, this tells us that 2 is our answer, and yes, for this particular question our answer is 2. The size of the magic square that is possible in this given grid is actually 2. Now one thing, now we have understood the question. Now the conditions, like many people actually don't see it, but conditions given is m and n are the length and the breadth of the grid, and m and n can only be 50. So this is what we need to understand. So I've just done the condition analysis. Over here, total elements that can be in maximum 50 cross 50 grid scenario, it can be 2500 elements. And what is the visiting time possible for 2500? So even if we do n square, that is 6.25, which is much less than 10 to the power of 8. So that is actually equivalent to 1 second time. So over here, this helps us understand that n square is actually possible over here. Now we have understood the condition, so we have got an idea that n square solution is actually possible. Now let's jump into the intuition. So given a grid 4 cross 3, what is the maximum square possible? That is 3 cross 3 for sure. But is it actually having all the criterias for the magic square met? Maybe not. But how can we check that? So we can go ahead and try all the 3 cross 3 grids. We can then try all the 2 cross 2 grids, and then we can go for 1 cross 1. But anyways, if there's only one element, then we have to return 1, because for one element it is always a magic square. So this is our way out. But don't you think we are repeating a lot of things? So firstly, in the grid over here, let me erase this. So what are we actually doing? We are going ahead and checking this, then we are going ahead and checking this, then we are going ahead and checking this. So computing the sum of all these squares again and again. Now if you'll see, these are actually getting repeated. These are getting repeated. So why do we have to do we see any redundancy over here? Yes, that redundancy is actually our way to optimize. Now what we can do is, we have found the redundancy that once, like sum should be calculated once. Now if you will be able to relate it to prefix sum, For any given array, suppose 513162, the example taken over here, there are two ways to find the sum of 316. What are those? One is iterative. Go to 3, go ahead, 3 plus 1 plus 6. That is one way. But the other is, if you have the sum till 6, if to have the sum till 6 and you minus the sum till 3, you'll get the sum of 316. Am I right? So over here, if I go ahead and create a prefix sum array, that is 5, 5 plus 1, 6, then 6, then all these 9, and then if I go for over here, we have 10, then so on and so forth. So you understand the concept that we are adding actually the all the elements over here and deriving the next element. So it becomes our prefix sum array. Now we have this 6, the position of 6 is actually 16. So sum till 16 is, sum till 6 is 16. Now we are going to subtract it with sum till 3, that is actually 6 over here. So now we do that and we get the answer 10, which is true. 3 plus 1 plus 6 is 10. This is our way to optimize our solution. Now going further, now let's see how we fit this concept into our actual question. So we are given a grid. We are given this grid. Now to get so we are given this grid 5131. Now what we can do, we have to find the row sum, we have to find the column sum. Can we pre-compute it? Absolutely yes. So what will be, we're gonna divide this given grid into two grids. One is row sum grid, second is col sum. So over here we see 5 plus 1 is 6, then 6 plus 3 is 9, and then plus 1 10. This is how we are going to compute the complete array. Over here, if you'll see, it is the sum of rows that we are computing. Over here it is the sum of rows, and over here it is actually the columns that are getting added. Once you understand why we are doing this, let's directly jump into the code and let's understand how we can implement this. Hi guys, so let's start into the implementation of our largest magic square. So we're gonna take this example into consideration, 51319331, which we have understood in our intuition as well. So the very first thing that we should be doing is creating our prefix row sum grid. So for prefix row sum grid, let's define the grid. Then for I in range length of grid, then we're gonna have the sum row, then attempt to actually calculate the sum till now, and then the column now our temp will be grid of I and j, so adding our current sum and then with the previous sum, and then we are gonna append it to sum row. Now with this we have our row in hand, we are gonna add it to our grid, and that gives us our prefix sum grid. Now we have to compute the same thing for our columns. we're gonna name it prefix call some grid, and we're gonna append it with the first row because that is gonna be same. Now we are gonna do the same thing for I in range. Now because we have added the first one already, we are gonna start with 1, then some call, same like before. Over here we are not maintaining temp because we have already taken prefix call some grid, and we are gonna do the addition in the previous row elements. You'll see just now. Like this. Over here grid should be of capital G. Yes. Now we're gonna append this into our grid, and we have our prefix call some grid as well. Now one thing that we discussed is to finding the maximum magic square possible. And what is that? That is nothing but the minimum of length and breadth of the given grid. Possible minimum of length of grid and length of grid 0. With this, now what we need to do is we need to iterate and reduce the size periodically and try for all the sizes. That is, we're gonna start with maximum magic square possible. So in the example in the left, suppose it's 3, and go till 0 and subtract by -1. So that is, we are going till 0 because if suppose we get size equals to 1, then we are going to return size, because if there is one element in the grid, that's a magic square. Now we are gonna go ahead and over here we are gonna check the condition of the magic square. For that we are going for each element, that is our element. Just a second, I think, yeah. Now we have to check the condition of magic square, and what was the condition? The row sum should be equal to col sum. That is our condition. Now we need to find the row sum. That will be prefix row sum grid same call plus size -1. But suppose if there is someone previous, so in this example 5131, we need to compute this sum of 1 3, sum till here and sum till 1. So how are we gonna subtract this? So if call equals to 0, else prefix row sum grid row call plus size minus 1 minus the previous. So prefix row sum grid, same row but call minus 1, and we're going to do the same for the column. I hope you are able to understand what are we doing. And same, we are going to subtract the previous one. And to optimize our solution, now we have to check for all the rows, but we have found for the one element that is the starting element. Now what we can do is we can check if row sum over here is not equal to call sum, then it's not possible, it is a magic square, we can go and continue. Otherwise we can keep the flag true, and now we need to find all the prefix rows. So for prefix row in range, starting from row plus size, because we are only computing till the maximum size possible or the current size. Then for each row sum, we are gonna say prefix row sum grid, same the previous one, prefix row call plus size minus 1, if call equals to 0, else prefix row sum grid prefix row call plus size minus 1, and subtracting the prefix row sum grid prefix row call minus 1. Now we have got the each row sum. What we are going to do is check if this is also same or not. The row sum found before, if not, then we're going to do flag equals to false and then break. We are not going to do continue because it will just exit from the current loop. We want it to exit from the main loop. Over here, just like this. Now we are gonna do same for prefix call. Then this is important. So we have now currently checked the row and the column, but there's one more condition. We have to check the diagonals. So we are gonna do diagonal 1 and diagonal 2 for I in range size. What will be diagonal 1? Diagonal will be grid of row plus I plus call plus I. Yeah, so this is what we are computing. For each step taken, we are actually doing row plus I and col plus I, and same for diagonal 2. Over here our row column will increase, but the column will start from maximum and decrease thereafter, just like this. Now if diagonal 1 is not equal to row sum, or diagonal 2 is not equal to row sum, continue. We have not found the solution yet. Then when everything falls true, return size, and this is if the condition passes and we have found the answer, we should directly return size. This is, let's just try and submit it. Yes, and now if we go ahead and submit, and we have our solution that is 97.7%. So thank you so much, and keep lead coding. Thank you.